We discuss today the general equation of second degree part 2, the reduction to the canonical form. We try to give some examples under which the classification what we have made in video number 1, part 1 on this topic can be explained very easily. So I am going, just you see the solution. Okay. First problem I discuss, reduce in canonical form. The equation is 3x square plus 2xy plus 3y square minus 16x plus 20 equal to 0. Mark it as equation number 1. Its general form is a square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. So comparing, we get a equal to 3, h equal to 1, b equal to 3, g equal to minus 8, f equal to 0, c equal to 20. We construct this matrix AHG, HBF, GFC. Actually this matrix is determinant can be obtained as minus 32 not equal to 0, and D is a terms involving the second degree terms, coefficient involving second degree terms, that is equal to 8. So not equal to 0. Delta not equal to 0 means rank 3, non-singular, and D not equal to 0 means it is a central conic. So under our category, this is NSCC, non-singular central conic, according to our abbreviation what we have discussed in part 1 of my video on this topic. So if it is, since it is central conic, we find alpha beta as the center. The center can be obtained 3 alpha plus 1 beta minus 8 equal to 0, 1 alpha plus 3 beta plus 0 equal to 0. By cross multiplication, we obtain alpha equal to 3, beta equal to minus 1. The first transformation, we have xy to x dash y dash. That is, we shift origin by means of the translation, means at x dash y dash, at alpha beta, we generate a new rectilinear system calling x dash y dash by the transformation x equal to x dash plus 3, y equal to y dash minus 1. We put this x and y into equation number 1 and simplifying, we will get the equation in the form 3x square x dash square plus 2 x dash y dash plus 3y dash square minus 4 equal to 0. This is number 2. Then we use the second transformation at the origin, in fact alpha beta, that is by the rotation through an angle theta. Rotation through an angle theta. X dash y dash to capital XY. The transformation equations are x dash equal to capital X cos theta minus capital Y sin theta. Y dash equal to x sin theta plus capital Y cos theta. We substitute this x dash and y dash into the equation 2. So on simplifying, we will get this equation. We will get this equation, that is equal to 4. It's not 0, it is equal to 4. It is equal to 4. Now, in order to remove the second degree term, because you know the standard form of a conic, suppose you know ellipse a square by a square plus y square by b square equal to 1. Hyperbola x square by a square minus y square by b square equal to 1. So, in the standard form, there is no xy term. So, since there is no xy term, we want to remove this xy term, that is cos 2 theta equal to 0, because theta is in our hand, and we can substitute theta equal to pi by, we can get theta equal to pi by 4. Putting this theta equal to pi by 4 on the equation number 3, we obtain the equation as x square by 1 plus y square by 2 equal to 1. This is the canonical form of this given equation. And seeing this one at that axis with respect to capital X and capital Y, that is obtained from xy to x dash y dash, then x dash y dash to capital XY. And this comes out to be an ellipse. Now we consider example number 2. reduce in canonical form, the equation is 4x square minus 4xy plus y square plus 2x minus 26y plus 9 equal to 0. Marked equation number 1. This is general equation of second degree. Its general form is x square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. So we can obtain a, b, c, f, g, h and c. We form the matrix. Now substituting the values, we get the values. Is determinant equal to minus 6 to 5 not equal to 0. And d forming with the second degree coefficients, that is equal to 0. This means that this is ns, nc according to our notation in part 1, non-singular, non-central conic. That is, it's a parabola. It's a parabola. As d equal to 0, second degree term, d means is discriminant, so it can be make a perfect square. We can make perfect square. So one can be simplified as 2x minus y whole square with this term minus the other term, the linear term and constant term. Now we introduce a constant lambda, this lambda to be determined later on. We are adding this lambda and squaring and adjusting the other terms. The first degree term x, first degree term y and the constant term, we get this equation. Just by putting this one and the terms adding over here, we subtract, we add in the right hand side. We add right hand side. Mark it as 2. So we get two lines. One lines we are getting, this is linear, that is within the square, and another as right hand part, the whole part. We write these two equations. So equation number 3 and equation number 4 represent the equations of lines. We choose lambda such that these two lines are perpendicular. So condition for perpendicularity, m1 m2 equal to minus 1. m1 is slope of line 3, m2 is slope of line 4. So slope of line 3, if we multiply, is equal to minus 1, it gives lambda equal to 3. For this value of lambda, equations 2, 3 and 4 can be simplified as this. Now you see that these are the lines 6, 7 are perpendicular lines. And we take these two lines as perpendicular lines, new x-axis and new y-axis. Let equation 6 is taken as new capital x-axis. Equation 7 is taken as new capital y-axis. Therefore, we mark this one. If we draw the diagram, this is our old axis, OX, OY, and this is the line. Suppose this is line number 6, this is line number 7. We are taking this is x-axis, we are taking this is y-axis. Now for a particular point P, whose old coordinates are xy, for the same point, the new coordinates is capital S, capital Y. Now what is capital X? Capital X is the perpendicular distance of the point P from the line 7. So 7 has the equation x plus 2y equal to 0. So perpendicular distance is capital X, x plus 2y by root over 1 plus 2 square by its formula. And similarly, capital Y is the perpendicular distance of 6 from the point P. So we obtain capital Y. This capital Y and this capital X and capital Y for the values of x plus 2y and this one, when substituted in the equation 5, we get capital Y square equal to 10 by root 5 into capital X. This is equation of parabola. This is equation of parabola. And this is the canonical form. Now we consider the example number 3. This is the example, reducing canonical form as example 1 and 2. This is the equation, general equation like this. Comparing this one, we find A, B, C, H, G, F, and this is the matrix A is G, H B F, G F C, delta equal to 0 but D not equal to 0. So what is the rank of A here? Rank of A equal to 2 because at least one second order minor is not equal to 0. Its rank equal to 2. So according to our part 1 video, so this is under category SPSI. We are denoting SPSI, that is singular pair of straight lines intersecting. A pair of straight line intersecting. So we can obtain pair of a point of intersection alpha beta that can be obtained from the first two rows because this is the giving the D part, D not equal to 0. So this is 6 alpha minus 5 by 2 plus 7 equal to 0 and minus 5 by 2 minus 6 alpha plus 5 by 2 equal to 0. Now we shift origin, first transformation, we shift origin at point alpha beta, the origin by the transformation x is equal to x dash plus alpha, y equal to y dash plus beta. So on substituting the equation, you will find that this is equal to 0 because this represents a pair of straight line. It will be in the general equation of second degree. It will be in the general equation of second degree, and you can find that the second degree term, the coefficient of second degree term remains intact. 6 minus 5 minus 6, 6 minus 5 minus 6 will remain the same. After this, we make a second transformation through a rotation through an angle theta, changing from x dash y dash to capital XY. By the transformation rule, x dash equal to capital X cos theta minus capital Y sin theta, y dash equal to capital X sin theta plus capital Y cos theta. If you substitute in the equation number 2, on simplification, we will get this equation number 3. To remove the xy term, we substitute this one. So if we put this is equal to 0, sin theta by sin 2 theta by minus 5, cos theta by 12 equal to 1 by 13. That is root over cos square 2 theta plus sin square 2 theta by root over minus 5 square plus 12 square. So we obtain sin 2 theta equal to minus 5 by 13, cos 2 theta equal to 13 by 12 by 13. So cos 2 theta is positive, sin 2 theta is negative. This means that all sin, tan, cos, the 2 theta angle lies in the fourth quadrant. So theta must be an angle which must be greater than such that 2 theta equal to in the fourth quadrant. So substituting this sin 2 theta and cos 2 theta into the equation 3, we get capital X square minus y square equal to 0. So this is the required canonical form of the equation. If we want to give the geometry of the problem, what we have, this is old axis, x axis, this is old y axis. We rotate, we obtain an angle theta such that sin 2 theta equal to this, cos 2 theta equal to this. So this we obtain the new axis capital X, this is new capital Y axis, and the two straight lines are like this. Capital X equal to Y and capital X equal to minus Y. Now consider another example. Example number 4. Reducing canonical form. This is the equation 4x square plus 4xy plus y square minus 12x minus 6y plus 5 equal to 0. As usual, we find general form. We obtain the constants coefficients. We consider the matrix A, AG, HBF, GFC. Its determinant found out to be equal to 0. It's clearly obtained from this equation. If you take 2 common from the first row, then first row and second row become identical. So D equal to 0, 4 minus 4 equal to 0. But another cofactor is, minor of order 2 is there. That is 1 minus 3 minus 3, 5, which is equal to 5 minus 6 not equal to 0. So rank of the matrix is A. Rank of the matrix is A, although D equal to 0. So under our category, what we have explained in part 1 of this video, we categorize this as SP, SP. That is singular, S for singular, determinant equal to 0, pair of straight lines, and parallel, pair of parallel straight lines. So we use here the first transformation xy equal to capital XY, because since D equal to 0, we don't get any point of intersection over here, so we directly make the rotation. We rotate through an angle theta by the formula x equal to capital X cos theta minus capital Y sin theta, small y equal to capital X sin theta plus capital Y cos theta. On substituting this into equation number 1, we obtain this one on simplification. As usual, we have to remove the second product term xy. So to remove product term, we obtain cos 2 theta by 3 sin 2 theta by 4 equal to 1 by 5. So cos 2 theta and sin 2 theta both in the first quadrant. So theta is in first quadrant. So obtain from the first quadrant value cos theta also positive, sin theta also positive. So it can be obtained from this equation. On substituting this cos theta and sin theta into this equation, we can find that the equation reduces to x minus root 5 into x minus 1 by root 5 equal to 0. So this is the canonical form. If we give the geometry of the problem, so this is old axis, x axis, y axis, and this is capital X rotated through an angle theta. This is rotated through an angle theta. Theta can be obtained from here. So this is x axis, this is y axis, this is one line. First line x equal to 1 by root 5, this is smaller one, and x equal to root 5, this is larger one. So this is the two parallel straight lines which canonical forms are x equal to root 5 and x equal to 1 by root 5. So this is the last example under this category, reducing in the canonical form 4x square plus 4xy plus y square minus 12x minus 6y plus 9 equal to 0. So if we compare with example number 4, instead of 5 we have written it as 9. Okay, 9. So comparing all these things, we find all the coefficients. We find the matrix A. What is the matrix A? This is 9 here. 4, 2 minus 6, 2, 1 minus 3, 6 minus 3, 9. So here delta equal to 0, D also equal to 0, and you can find that all the second order minors are equal to 0. And we can say that if we take 2 common from the first row, this is 2, 1, minus 3. If you take minus 3 common from here in the third row, this is 2, 1, minus 3. So 3 rows of the matrix A are not independent. In fact, only one independent row we are getting. So its rank is 1. Since rank is 1, we got the category as discussed in part 1, SPSC, that is singular pair of straight lines coincident. So we use the transformation since we are not getting any point of intersection. So there is no question of the translation. So we directly convert from xy to capital XY through the rotation theta. X equal to, we obtain capital X cos theta minus capital Y sin theta, y equal to capital X sin theta plus y cos theta, as in formula for rotational transformation through an angle theta. On substituting this equation number 1, we simplify to this equation number 2. As we know, we have to remove the xy term. We obtain this one, cos 2 theta by 3, sin 2 theta by 4 equal to 1 by 5. So you can see that both cos 2 theta and sin 2 theta are positive. So 2 theta lies in the first quadrant. So theta is in first quadrant, and cos theta equal to positive 2 by root 5, sin theta equal to positive 1 by root 5, and hence equation 2 is reduces to the equation 5x square minus 6 root 5x plus 9 equal to 0. Plus 9 equal to 0. So this can be made a perfect square, root 5 into x minus 3 whole square. So we get two equal straight lines, that is coincident straight line, x by 3 root 5, y x equal to 3 root 5. So we have rotated through an angle theta, and we obtain a straight line x is equal to 3 by root 5. So this is the canonical transformation when the equation is given this one and it is identified to be a equation with rank 1 with the coefficients, and that to be under SPSC. So friend, as we have discussed in part 1, we are completing the whole chapter, what we call the general equation of second degree in 2 dimensions, and the 5 categories is explained with 5 examples. The first one, that is why in the first video we have made the classification, and the classification is important. Depending on the classification, we make the strategy how we convert from xy to x dash y dash by translation, or xy x dash y dash to x capital Y through rotation, or a single one. So we finish this video over here on the general equation of second degree 2 dimension. Hope you will be enjoying this video and you can learn a lot. I will eagerly waiting from any comments after seeing this video, and keep enjoying and subscribe my channel. Thank you.